P. First, first in this we will discuss in this chapter we will discuss different types of fundamental particles, their properties, and we will see how it is classified. Now, again, these fundamental particles is classifying using various methods, and we will see the conservation laws for to be followed for producing the elementary particles, and we will see the quark model in this chapter. Unit number 12, block number 4. First, we will see the introduction. In introduction, actually, what is this elementary particles? In the universe, we are seeing is many number of particles. In that, we have very, very small particles. Suppose I am dividing a small particle into sub-particle. Again, that sub-particle is divided into more sub-particles. So, this nature is of filled with particles. So all the nature is filled with these particles. So such type of particles is called as elementary or fundamental particles. So what is fundamental particle? Universe is consist of small particles. That particle is further it is divided until it is indivisible. So ఎక్కడ వరకు మనం డివైడ్ చేస్తున్నాం, further it is not possible to divide. Up to that extent we are dividing the particles. These particles is called as fundamental particles. So Greek, so it is came the atom, the name atom came from Greek root called atom. What is the meaning of atom in general? The atom meaning is indivisible, means we cannot divide further. We cannot divide it further. So afterwards, Rutherford showed that atom consists of small nucleus. Rutherford, what he said, atom consists of a small dense nucleus. This nucleus is surrounded by electrons. Suppose this is nucleus. This nucleus is surrounded by electron. This nucleus is surrounded by electron. Inside the nucleus, what we have? Inside the nucleus, we have proton and neutron. P is represented with proton, N is represented with neutron. So that one is written in the next line. The nucleus is further broken into small particles. Those particles is called as protons and neutrons. Next. And after recently what we are saying, this instead of proton, neutron, so the particles is made up of quarks. Particles is made up of quarks. So all these are introduction part. Again, this whatever the particles we have, which type of interaction it is taking place, whether the interaction between the particles is strong interaction, whether the interaction between the particles is weak, then it is called weak interaction, and if electromagnetic interaction, which type of interaction is taking place between the particles, I will also observe. Next, we will observe kaons, pions, together with baryons grouped into strongly interacting particles. So here we will take hard ions. We will call the term hardons. Hardons is strongly interact. Balamaina cheryalu anamata. This is strongly interact. In this strongly interact, what are the things will come? Kaons, pions, together with baryons. These three together is called as hard ions. What is the hard ions? Hard ions is a strongly interacted, which kaons, pions, baryons and comes under this one. Next we will see this hard ions is explained. This hard ions is explained using a quark. Using a quark, this hard ions is explained. So this comes under introduction. Next we will see what are the various elementary particles we have. Next topic is various elementary particles. The various elementary particles. The various elementary particles, what we have? The various elementary particles is basic particles. We have electron, proton, neutron, and photon. These are the basic particles. So here is given electron, proton, neutron, and photon. These are basic particles. These protons and neutrons, where it is? The protons and neutrons is inside the nucleus. Nucleus lopal untadi. Whereas this electron is outside the nucleus. So These protons, neutrons, and electrons are building blocks of the atom. The electron is lightest particle and having some rest mass, some mass ఉంటుంది అనమాట. And so electron having negative charge. So electron ki some lightweight particle, some rest part ఉంది. దీని charge ఏంటి? This charge is negative. Next we will take proton. Proton is represented with P, which it has positive charge, and its mass is equal to 1038 6 times of the mass of the electron. Next we will take neutron. Neutron is represented with N. Its mass is written as 1039 times of mass of the electron, and neutron charge is 0. The charge of neutron is 0. Next we will take photon. So first description is electron, second description is proton, third description is neutron. Next fourth description we have. And what is the fourth description? Fourth description is photon. Fourth description is photon. Now here what is photon? Photon is a quantum unit of radiation. So this photon is produced by electromagnetic energy. This proton produces electromagnetic energy, and E equal to photon E equal to mc square. E is energy, m is the mass, c is the velocity of the light, and the charge of the photon is 0. The charge of the photon is 0. Next we will discuss about the spin of each one. We will see about the spin of each one. Whatever the photon I said, its charge is 0. Its spin is equal to 1. For photon, the spin is 1. For electron, proton, neutron, what is the value of spin? Spin equal to 1/2. So this electron, photon, neutron, these three are obeying Pauli's exclusion principle. Pauli's exclusion principle. Electron, proton, neutron, these three are executing Pauli's exclusion principle. So we will call this as a Fermi-Dirac statistics. So this is we can solve these problems using Fermi-Dirac statistics. Whereas this photon is not following Pauli's exclusion principle. Pauli's principle it is not following. So if it is not following Pauli's principle, I will say that it is following Bose-Einstein statistics. So here the final conclusion is electron, proton, neutron is following. It is obeying, not following. It is obeying Pauli's exclusion principle. So we will call it as the statistics, whatever we will say, consider is Fermi-Dirac statistics. Whereas photon is not obeying Pauli's exclusion principle. Pauli's exclusion principle not obeys. Pauli's exclusion principle not obeys, as it is not obeying Pauli's exclusion principle. So here the statistics, whatever I am calling is Bose-Einstein Bose-Einstein statistics. So this is about which topic we discuss? This is about various elementary particles. So what are the content we have to cover in various elementary particles? The various elementary particles అంటే electron, proton, neutron గురించి రాయాలి. తర్వాత వాటి masses రాయాలి, వాటి spin రాయాలి. Which type spin రాసాక which type of statistics follow అవుతుంది? Electron, proton, neutron కి Pauli's exclusion principle obey చేస్తుంది కనుక that is Fermi-Dirac statistics. Next photon is Bose-Einstein statistics. Next we will see about antiparticles. What comes in antiparticles? Positron. Actual electron is represented with E minus. E minus ante endi kada electron. Next I am writing E with plus sign. What is this mean? This is positron. This is positron. It is developed by whom? P.A.M. Dirac of England scientist. Actually, as per his theory, he took wave property and he simplified Dirac's wave equation. He simplified what? He simplified he simplified Dirac wave equation for the electronic. There he observed two frequencies. One frequency he observed is negative frequency. Another frequency, whatever he observed, is positive frequency. And he proved that electron consists of positive charge. Dirac wave equation is simplify చేసిండు ఎలక్ట్రాన్ యొక్క డైరాక్ వేవ్ ఈక్వేషన్ ని సింప్లిఫై చేశాడు. డైరాక్ వేవ్ ఈక్వేషన్ ని సింప్లిఫై చేశారు. చేసి ఏమని చెప్పాడు? ఇట్ హ్యాస్ టూ ఫ్రీక్వెన్సీస్. హౌ మెనీ ఫ్రీక్వెన్సీస్? టూ ఫ్రీక్వెన్సీ. One frequency is in terms of negative, another frequency is in terms of positive. Again, he said that he observed electron with positive charge. This electron with positive charge is called as positron. Suppose when positive electron is collide with negative electron. Suppose I have electrons like positron I have, another one is electron. When these two cases are collide with each other, what happens? When these two are collide with each other, then it is converted to photon. That is mentioned here. See, the last line. When positive electron collide with negative electron, it annihilate each other and it is converted into photons with equal amount of energy. Photon with equal amount of energy. The final conclusion of positron is E plus. We will show. Who derived this one? Dirac derived the wave equation. After deriving, he observed two frequencies, negative frequency and positive frequency. Again, he said that he observed one electron with positive sign. This is called as what? Positron. When positive charged electron and negative charged electron both are collide with each other, one photon is forming. What is forming? One photon is forming. These are the points you have to cover in positron. Positron, which one we discussed? Positron. These are the things has to be covered in positron. Next, antiproton. Next topic is antiproton. How to produce this antiproton? What are the properties of this antiproton? Proton is represented with P. Proton is represented with P. Antiproton is represented with P bar. So antiproton charge ఏముంటుందమ్మా? Antiproton charge is -1. Whereas what is photon charge? Proton యొక్క charge is +1. Antiproton charge is -1. And we have few points, properties. What is the first one? The mass is same as proton. Proton యొక్క mass ఎంత ఉంటుందో same mass. Again, what is the charge? We have charge of -1. Next, this is stable and it lasts long in a vacuum. So, ఇది ఒక stable particle. This is a stable particle. Next, when this antiproton meet with neutron or proton, suppose this antiproton is joined with proton. or this antiproton is joined with neutron. So it is disappears. It disappears and produces two particles. How many particles it will produce? It will produce two particles. Next one is uh, we cannot separately produce this antiparticle. Suppose I producing antiparticle separately is not possible. Compulsory it has to produce either with proton or neutron. Individual production of antiparticle is not possible. So what is the equipment used for producing this antiparticle is I'm taking a equipment called betatron. This is the betatron. This betatron, here I'm applying 6 billion electric volt electric volt energy is applied to this equipment. Then 4 antiprotons are produced. To produce antiprotons, what is the equipment is used? To produce the antiproton, the equipment is used. Betatron is designed for this purpose. How much energy is required for this one? 6 billion electric volts of energy is required. So a copper was bombarded. Copper was bombarded with 6 mega electric volts of protons. Then finally, 4 antiprotons are produced. So this is when they found this one. This is the did this experiment in 1955. So this is about antiprotons. First properties across 6 mega electric volts using betatrons, antiprotons are produced. Next one is neutron. What is neutron? Neutron is different. Neutron is different. Neutron is only N. Neutron is only N. Another one when we have neutron. First, what is neutron N? Neutron N is the combination of proton and electron. Proton charge entundi? -1. Proton charge is +1. Electron charge is -1. Based on these two, we will get neutron charge as 0. But what we are discussing? We are discussing neutrino. If we are coming across neutrino, it is the combination of proton and neutron. It is the combination of proton and neutron. Is the neutrino. What is the mass of this neutrino? The neutrino mass is the mass of proton and electron. రెండిటి mass కలిపితే వస్తుంది కదా. So the mass of neutrino is the combination of proton mass as well as neutron mass. And this is lighter the mass of proton and neutron. Next, what are the properties is given here? Before discussing it is obeying Pauli's exclusion principle or not. First, we will see if it obeys Pauli's exclusion principle, it is comes under Fermi. If Pauli's exclusion principle is not obeying, it is comes under Bose-Einstein statistics. Here, what is saying here? Pauli suggested another particle with 0 rest mass. So here we are discussing about neutrino. Neutrino has 0 rest mass. 0 rest mass. Neutrino has 0 rest mass. Next, we have few properties and it is invisible particle. This is called as invisible particle. The name is neutrino. What are the properties? Its charge is 0. First property is charge is 0. This is weightless particle. And what is the mass of neutrino? Mass of the neutrino is 0. Mass of the neutrino is mass of the proton plus mass of the electron. Electron mass plus proton mass, total mass to 0 consider just now. Next, what is its spin? Its spin equal to 1/2. Where it is produced, it must have birth in beta decay. Beta decay produce చేసేటప్పుడు ఇది వస్తుంది. So this is about neutrino. This is about neutrino. After discussing about neutrino, the next one is pion. After discussing neutrino, The next one is pion. Pion represented with pi. Again, it is of three types: pion with positive charge, pion with negative charge, pion with zero, neutral charge. What is this one? Actually, what happening with this one? Who proposed this one? This is proposed by physics to Japanese physics scientist called Yukawa. He proposed nucleon emit and absorb the quantum radiation called as meson. And whatever the forces is there across the nucleus, those are short range forces. He said, and what is its mass? What is the mass of the pion? And pion mass ఎంత, దాని లైఫ్ టైం ఎంత, దాని ఛార్జ్ ఎంత, ఇవి చూద్దాం. సో టోటల్ వీఆర్ టేకింగ్ 3. పయానం మ్యూనం మనం చూసేది పయాన్. వీఆర్ చెకింగ్ పయాన్. First we will see the mass of the pion. Suppose if it is pion with positive, then its mass is 273.2 times of mass of the electron. It's times of the positive, and we are calling this as a positive pion. ఏమంటాం? Positive pion అంటాం. Next negative pion. What its mass? The negative pion is, its mass is equal to 264 times of the mass of the electron and 264 times of the mass of the electron. Next, its lifetime. Its lifetime. Lifetime ఎంత ఉంది? Lifetime, its lifetime equal to 10 to the power of minus 15 seconds. This is its lifetime. Next, how pi plus pi minus and pi naught is produced. Pi naught, how we are getting pi? First pi plus. Pi plus is produced by muon plus positive neutrino with neutrino positive. Next, pi minus is produced. How pi minus is produced? Pi minus is produced with muon plus neutrino, negative neutrino. Next, pi naught. Pi naught, how it is producing? Pi naught is producing by emitting gamma radiation. This is about pions. Here its masses is important, its lifetime important, and how equations are produced. Next, we will see muon. Here, like pions, we have three types variations we have in pions: pi plus, pi minus, pi zero. Whereas in the muons, we have only two types: mu plus, mu minus. Mu plus and mu minus. So what is its lifetime is mentioned in this? Its lifetime is not mentioned in this. How we are getting this pion muon equations, we will see. Muons is unstable. These muons are stable or unstable? These muons are unstable particles. These muons are unstable particles. First point. These muons are produced in a cloud chamber photographic cosmic radiation law. These are produced in Harvard University. When cosmic rays are traveled through the atmosphere and it is penetrated and collected in the, detected in the deep mines. What is its lifetime? Its lifetime ఎంత? 2 microseconds. Pion's lifetime ఎంత చెప్పాము మనం? Pion's lifetime is 1.5 microseconds చెప్పాము. Pion's lifetime 1.5 చెప్తాము. Pion కి లైఫ్ టైం ప్రీవియస్ 10 to the power of minus 15 తీసుకున్నాం. Pion కి లైఫ్ టైం ఎంత ఉంది? Pion కి లైఫ్ టైం ఎంత ఉంది? 10 to the power of minus 15 తీసుకున్నాము. Muon కి లైఫ్ టైం ఎంత ఉంది? Muon కి లైఫ్ టైం ఎంత ఉంది? 2 microseconds ఉంది. మళ్ళీ తర్వాత ఇది అన్స్టేబుల్ పార్టికల్. నెక్స్ట్ that how it is formed. Pion అనేది ఎట్లా ఫామ్ అవుతుంది ఒకటి మ్యూ అని కదా మనం డిస్కస్ ఒక మ్యూ ప్లస్ ఎట్లా ఫామ్ అవుతుంది మ్యూ మైనస్ ఎట్లా ఫామ్ అవుతుంది మ్యూ ప్లస్ ఫామ్ కావడానికి ఒక పాజిట్రాన్ తీసుకోండి ప్లస్ న్యూట్రినో తీసుకోండి యాంటీ న్యూట్రినో పార్టికల్ తీసుకోండి ఈ 3 కాంబినేషన్ లో మనకి మ్యూ ప్లస్ ఫామ్ అవుతుంది నెక్స్ట్ మ్యూ మైనస్ ఎట్లా ఫామ్ అవుతుంది మ్యూ మైనస్ ఇస్ ఫార్మ్డ్ విత్ ఎలక్ట్రాన్ విత్ న్యూట్రినో అండ్ యాంటీ న్యూట్రినో కాంబినేషన్ ఈ 3 కాంబినేషన్స్ తీసుకుంటే మనకు వచ్చేది మ్యూఆన్ సో మ్యూఆన్ ఏం చెప్తాం క్లౌడ్ చాంబర్ ఫోటోగ్రాఫ్ కాస్మిక్ రేడియేషన్ ని క్లౌడ్ చాంబర్ మీద చేసినప్పుడు మనకి మ్యూఆన్స్ అనేది వస్తుంది వాటి లైఫ్ టైం 2 మైక్రో సెకండ్స్ మాత్రమే ఉంది ఆ మ్యూఆన్స్ యొక్క స్పిన్ ఎంత ఉంటుంది మళ్ళీ స్పిన్ అనేది 1/2 ఉంటుంది యాక్చువల్లీ మ్యూఆన్స్ అనేది అన్స్టేబుల్ ఈ మ్యూఆన్స్ అనేది అన్స్టేబుల్ పార్టికల్ ఇది 2 టైప్స్ ఉంది ఒకటి మ్యూ ప్లస్ అని ఇంకోటి మ్యూ మైనస్ ఒకటి మ్యూ ప్లస్ ఉంది ఇంకోటి మ్యూ మైనస్ ఉన్నది మ్యూ ప్లస్ ఎట్లా ప్రొడ్యూస్ చేస్తున్నాము పాజిట్రాన్ ప్లస్ న్యూట్రినో ప్లస్ యాంటీ న్యూట్రినో నెక్స్ట్ మ్యూ మైనస్ ఎలా ప్రొడ్యూస్ చేస్తున్నాం ఎలక్ట్రాన్ న్యూట్రినో ప్లస్ యాంటీ న్యూట్రినో తోటి మ్యూఆన్ ప్రొడ్యూస్ చేస్తున్నాం నెక్స్ట్ వి విల్ సి స్ట్రేంజ్ పార్టికల్స్ నెక్స్ట్ టాపిక్ ఇస్ స్ట్రేంజ్ పార్టికల్స్ సో యాక్చువల్ ఏమైందంటే 1950లో ఫ్యూ న్యూ పార్టికల్స్ ఆర్ డిస్కవర్డ్ 1950లో few new particles are discovered. What are the new particles discovered? Hmm. 1950లో large new particles are discovered అయింది ఎప్పుడు 1950లో new particles are discovered. Actually how they discovered this? In the cloud chamber of photographs when high energy cosmic rays strike on the lead plate. ఒక lead plate తీసుకున్నాను అక్కడ కాదు ఒక ప్లేట్ తీసుకున్నాను ఇది లెడ్ ప్లేట్ దీనిపైన ఈ లెడ్ ప్లేట్ పైన హై ఎనర్జీ కాస్మిక్ రేస్ వచ్చి ఫాల్ అయ్యాయి హై ఎనర్జీ కాస్మిక్ రేస్ వచ్చి ఒక లెడ్ ప్లేట్ పైన ఫాల్ అయ్యాయి సో ద అవుట్పుట్ వాట్ ఎవర్ విల్ గెట్ ఐఎమ్ కలెక్టింగ్ దిస్ వన్ అండ్ ఫోటోగ్రాఫిక్ ప్లేట్ ఒక ఫోటోగ్రాఫిక్ ప్లేట్ పైన కలెక్ట్ చేశాను వాట్ ఎవర్ the result got in photographic plate, this is observed. If it is observed very clearly, a V shape is observed. Which shape? A V shape is observed in that photographic plate. A large number of V photographs were collected. So, if after studying, carefully studied, what we understood? That V shape consists of one K particle. V shape consists of one K particle and one lambda particle. మనకు V shape లో ఉందా అవుట్పుట్ లో మనకి ఏమొచ్చింది ఫోటోగ్రాఫిక్ ప్లేట్ పైన ఇన్ అవుట్పుట్ ఇన్ ద ఫోటోగ్రాఫిక్ ప్లేట్ వి గాట్ V shape. After clearly observing of that V shape, it is understood that 2 new more particles is observed. What are the 2 new more particles? One is kaon, another one is lambda. What is? One is K and another one is lambda. Now we will see the properties of K and the properties of lambda. Now we will see the properties of K, properties of lambda. First one is lambda we will take. So what I said? Lead plate. To this lead plate, cosmic rays is fall on this lead plate. After falling cosmic rays on this lead plate, the result of output, whatever we are getting, that is collected on photographic plate. In this photographic plate, one V shape is formed. That V shape represents new one is K and new particles called K and lambda. First, we will see the properties of lambda, how lambda is forming. Subheading is lambda. How lambda is forming? Lambda is formed with proton and P naught. Lambda is formed with P and P naught and lambda mass. The mass of the lambda is how much? The lambda of mass equal to 2181. 2181 times of the mass of the electron. And what is the spin of this lambda? Lambda spin equal to, what is the spin of this lambda? Lambda of the spin equal to 1/2. Next, another name for this lambda is called as, we can call this as a lambda or we can call this one as meson. We can call this fermi also. Mhm. We can call lambda, or we can call this one as a lambda or fermion. And the lifespan of this lambda, how much? The lifespan of this lambda is equals to 2.7 into 10 to the power of minus 10. This is the lifespan of lambda. Next, we will see the features of K. I said two is observed. Two particles are observed. One is lambda, another one is K. So all these are the features of lambda. And also we can form this lambda. How we formed lambda? We formed lambda equal to 1 proton plus P naught, or we can form in lambda in another method. Lambda we can form with neutrino, positive neutrino with pi naught. This is also another combination of forming lambda. So all the features of lambda is completed. Now we will see the features of K. Now we will see about K. How K is forming. K is formed using pions, pi plus pi minus. K is formed using pi plus pi minus, and the spin of this K, spin of this K equal to 0. Spin of this K and I spin equal to 0 and mention there. What is the spin? Spin equal to 0. And what is its lifetime? Same how we wrote for lambda, same way we had to write. The lambda, the lifetime of K is 1.2 into 10 power minus 8. It is the lifetime. And what is its mass? Mass equal to 965 times of mass of the electron. 965 times of the mass of the electron. I am writing down 965 times of mass of the electron. This is the mass of the kaon. Mass of the kaon. Not only this, few more particles is also invented. Not only k comma lambda, few more particles is also invented. We wrote features of K. We wrote V shape లో వచ్చింది మనకి photographic plate పైన ఏమొచ్చింది V shape వచ్చింది. After clearly studying of that V shape, we observe that two ions are formed. One is K and another one is lambda. Not only these, few more also observed. What are the few more which we observed? The few more particles that we observed are sigma, sigma and chi. These are also observed. Two more particles. How many particles observed? Two more particles are observed. Two more particles also observed. And neutrino. Neutron enti N kada. Anti-neutron is also observed. So, final, what is our topic? Strange particles. In strange particles, what are the things finally? What is produced in the strange particles? One lambda found, K కనుక్కున్నాము. Next తర్వాత sigma కనుక్కున్నాము. Next తర్వాత chi కనుక్కున్నాము. Not only chi, and next we found another one, anti-neutron. So, this strange particles లో new 5 particles అనేది invented అయిపోయింది. What are the particles? Lambda, K, sigma, chi, and n bar. All these are newly found particles, strange particles we found by using cosmic rays and cloud chamber. This is about strange particles. After discussing strange particles, we will go for classification of elementary particles, how the elements are classified. The elements are classified using 4 methods. First one is based on their stability. First, we will see side headings and we will go one by one. Hmm. Elementary particles is classified. First is based on stability. Stable, which particles are stable, which particles are unstable అని categorize చేసినాం. Next, based on first one is based on stability and second one is based on nature. What is the second one? Based on the nature. Third one is based on the spin. Spin ప్రకారంగా కూడా classify చేస్తారు. Next, fourth one is based on their mass. Based on the mass. So 4 ways it is classified. Stability is which are the things comes under stable, which things are comes under unstable అనేది ఒక categorize చేస్తున్నారు. Next, based on their nature, which type of interaction ఉంది మనకి అనేది based on the nature వస్తుంది. Next, spin, which type of spin 1/2 ఉందా, spin 0 ఉందా, or spin -1/2 ఉందా. Next, based on their masses, mass బట్టి కూడా categorize చేస్తాం. First one we will see based on its stability. Based on stability, which are stable, which are unstable. First, we will categorize. Next, we will go for the next one. Here, which are stable, which are unstable. We will list out first. Electron, proton, neutron, photon. These 4 comes under stable. These 4 comes under stable. What are the things comes under unstable? What are the things comes under unstable? In unstable, sometimes we will say also neutron. Unstable. First, we will consider neutron. Neutron can be treated as unstable as well as muon. In mu, what are the things we have? Mu minus, mu plus. Next, pion. Pion lemni, pi minus, pi plus, pi 0. Pi minus, pi plus, pi 0. All these things comes under unstable. After that, just see the table. What is the table is given? Symbol, particle, its charge, mass, spin, lifetime, and corresponding antiparticle. Just see here first, what is the symbol? Electron, E minus. This minus means charge is -1. What is the mass of the electron? Mass of the electron is 1. What is its spin? Spin is 1/2. What is its antiparticle? Positron. Electron ki antiparticle ఏమొస్తుంది? Positron. And next, what is the next one? Neutron. Neutron is represented with nu. Neutron is represented with nu. And its antiparticle is nu plus. What is its mass? Mass is 0. Spin is 1/2. Charge is 0. Next, proton means we have P plus. P plus and charge +1. Its mass, its spin, and its antiparticle is P bar. Next, photon. Photon is represented with gamma. Its charge is 0. Mass is 0. And its spin is 1. And it is comes by gamma radiation, emission of gamma radiation. Antiparticle. particle, antiparticle, rendu gamma we will write. Both are gamma. Next, all these lists comes under stable particles. Next, come to unstable particles. In the unstable particle, so neutron అనేది either it is stable or unstable based on the working. Based on the working and its status. This neutron sometimes it is in the stable state, and sometimes it is in unstable. Whether it is stable or unstable, it depends upon the nature when it is working. So what are the unstable particles? ఇక్కడ న్యూట్రాన్ వస్తుంది. The unstable particles are neutron వస్తుంది, muon, mu plus mu minus రెండు తీసుకుంటాం ఇక్కడ, ప్లస్ చార్జ్ మైనస్ చార్జ్, పయాన్ పై ప్లస్ ఉంటే పై మైనస్ ఉంటుంది, ఇన్పుట్ లో పై ప్లస్ ఉంటే ఇక్కడ ఏముంటది పై మైనస్ ఉంటుంది. ఇన్పుట్ లో పై మైనస్ ఉంది అనుకోండి, అవుట్పుట్ యాంటీ పార్టికల్ ఏమొస్తుంది పై ప్లస్ వస్తుంది. అండ్ న్యూట్రల్ పయాన్ పి నాట్, దీని చార్జ్ 0, మాస్ ఇస్ గివెన్, what is its spin is given. This is about based on its stability. Next one is based on nature. Nature అంటే ఇక్కడ 4 types of forces act చేస్తుంది. One is gravitational force. What is the first one? First one is gravitational force. Second one is electromagnetic force. Third one is strong interactive force, strong interaction. Fourth one is weak interaction. Which type of interaction is there? First one is gravitational force. In Newton's laws, Newton's gravitation law, G is inversely proportional to square of the distance. So this is inversely proportional with the square of the distance. Inversely proportional to the square of the gravitation is inversely proportional to the square of the distance is the gravitational force. Next interaction is what? Next interaction is electromagnetic interaction. In electromagnetic interaction, electron is kept in an electromagnetic field. Electron is where this electron is kept? Electron is kept in electromagnetic field and continuously emitting as well as absorbing photons. The photons are continuously emitted and absorbed. Next is a force of attraction is if it is a strong force. If force of attraction is weaker, that is called weaker. So based on nature ante strong force unda, weak interactive force unda. Next, whether it is gravitational force or electromagnetic force. Based on that one, it is divided. Nature ante 4 points that. Next, based on spin. Next spin lo em cheppan Pauli's exclusion principle follow avute avi fermions aitadi. For which one? Electron, proton, neutron, electron, proton, neutron. Starting lo cheppam. Electron, proton, neutron endi Pauli's exclusion principle follow చేస్తుంది. Electron, proton, neutron Pauli's exclusion principle ni follow చేస్తుంది. So Pauli's exclusion principle, if it is follows, it comes under Fermi-Dirac statistics. Suppose photons. Photons అనుకోండి. Next ఏంది photons. ఈ photons అనేది Pauli's exclusion principle not follows. Not following Pauli's exclusion principle. PEP ante Pauli's exclusion principle. If it is not follows, it comes under Bose-Einstein statistics. If it is not following, it comes under Bose-Einstein statistics. Next is based on their mass. Based on their mass, again it is divided. Based on the mass ante మన పార్టికల్స్ ఏవైతే ఉన్నాయో మనకి వాటి మాసెస్ ఏమున్నాయి అండ్ దాన్ని బట్టి దాన్ని కేటగరైజ్ చేస్తాం అనమాట. బేస్డ్ ఆన్ ద మాసెస్ లో ఇక్కడ ఏం చెప్పాలి, హెవీ పార్టికల్స్ ఏంటి, లైట్ పార్టికల్స్ ఏవి లిస్ట్ మెన్షన్ చేయాలి. విచ్ ఇస్ కమ్స్ అండర్ హెవీ పార్టికల్స్. హెవీ పార్టికల్స్ కి మాస్ ఇస్ మోర్, ఫర్ లైటర్ పార్టికల్స్ మాస్ ఇస్ లెస్. Based on the masses, it is categorized. So here what is mentioned in this, leptons are lighter particles. Second point, leptons are lighter particles. Which is comes under leptons? I will write here what are the lighter particles we have. What are the list comes under lighter particles? In lighter particles, we have electron, muon, ఇంకోటి neutrino. Electron, muon, neutrino. This is called as lighter particles. The name of this one is also called as leptons. Lighter particles, another name is leptons. Next, heavier particles. What are the things comes under heavier particles? What are the things comes under heavier particles? Neutrons, protons, hyperons. Heavier particles కిందకి వస్తుంది న్యూట్రాన్స్, ఇంకోటి protons. Neutrons and protons called heavy particles. The another name for this one is also called as hyperons. Also called as hyperons. Heavy particles is another name is called as baryons. Another name for this one is another name for baryons. Next we have another term called hard ions. This hard ions is the combination of mesons and baryons. Hard ion is a combination of Ardans is the combination of mesons and baryons. This is about the classification is based on their masses. So, మనకి next table ఇచ్చాడు. ఆ table ఏం చెప్పిండు? Which particle and what is its mass is mentioned in this table. చూడండి, symbol mass. Fermions. Fermions లో ఏముంటది? Fermions or baryons. Proton spin 1/2 ఇచ్చిండు. నెక్స్ట్ బోసాన్స్ మెన్షన్ చేసాడు. స్పిన్స్ 0 and 1s. సో బోసాన్స్ కింద ఏమేమి లిస్ట్ ఉన్నా చూడండి. బోసాన్స్ కి లిస్ట్ ఏముంది? బోసాన్స్ అన్ని బోజానిస్ట్ స్టాటిస్టిక్ ఫాలో చేస్తుంది. కేయాన్స్, పయాన్స్, ఫోటాన్స్. Kaons, pions, photons is called as Bose-Einstein statistics or bosons with spin 0 or 1. And next, spin 1/2 ని 3 parts గా డివైడ్ చేసిండు. ఒకటేమో లెప్టాన్స్, ఇంకోటి న్యూక్లియస్, ఇంకోటి కై, సిగ్మా, లాంబ్డా, ఒమేగా. లెప్టాన్స్ లో ఎలక్ట్రాన్, న్యూట్రినో, muon. Nucleus is N. This is about what we discussed. This is about classification of elementary particles. Next we have conservation laws is another one topic is there. Another topic is quarks. In this lesson, we will see conservation laws. This conservation laws means one is conservation of linear momentum. We have conservation of angular momentum. Subheadings what we have? Conservation of linear momentum. Conservation of linear momentum, it is conserved in the direction. It is conserved in any one of the direction. So linear momentum is conserved in the direction. Then this is called conservation of linear momentum. The example is Compton effect. Next, conservation of angular momentum. Conservation of angular momentum అంటే ఆర్బిటల్ యాంగులర్ మొమెంటం L ఉంటుంది, స్పిన్ యాంగులర్ మొమెంటం S ఉంటుంది. సో కన్జర్వేషన్ ఆఫ్ యాంగులర్ మొమెంటం ఇస్ అ కాంబినేషన్ ఆఫ్ L and S. conservation of angular momentum it is the combination of L and S. ఇందులో మళ్ళీ స్ట్రాంగ్ ఇంటరాక్షన్స్ ఏంటి, వీక్ ఇంటరాక్షన్స్ ఏంటి అని మెన్షన్ చేయాలి లిస్ట్. కన్జర్వేషన్ ఆఫ్ యాంగులర్ మొమెంటమ్ లో స్ట్రాంగ్ ఏంటివి, వీక్ ఏంటి. ఫస్ట్ we will write strong interactions in this. స్ట్రాంగ్ ఇంటరాక్షన్ లిస్ట్ లో ఏమొస్తాయి, సిగ్మా. స్ట్రాంగ్ ఇంటరాక్షన్ లిస్ట్ లో ఫెర్మియాన్స్ తీసుకుందాము. ఫెర్మియాన్స్ కి మనకి ఏమేమి ఉన్నాయి, సిగ్మా, లాంబ్డా, కేయాన్ అండ్ ప్రోటాన్. ఫర్ ఫెర్మియాన్స్ లో ఈ కాంబినేషన్స్ స్ట్రాంగ్ ఇంటరాక్షన్స్ విత్ స్పిన్ ఎంత, వీటన్నిటికి స్పిన్ 1/2. నెక్స్ట్ వీ హ్యావ్ ఇందులోనే దీనికి స్పిన్ 3/2 ఉంది. ఇప్పుడు మనం ఏం చూసాం, ఫస్ట్ వన్ చూసి స్ట్రాంగ్ ఇంటరాక్షన్స్ లో ఫెర్మియాన్స్ చూసాము. నెక్స్ట్ ఇస్ స్ట్రాంగ్ ఇంటరాక్షన్స్ లో బోసాన్స్ చూద్దాం. Bosons in strong interactions. Whatever we have boson strong interaction list ఉంది. న్యూట్రియాన్, K, pi, ఈ 3కి స్పిన్ 0 ఉంది. నెక్స్ట్ వీక్ ఇంటరాక్షన్ లో చూద్దాం. థర్డ్ వన్ ఏంది, ఇది సెకండ్ వన్. బోసాన్స్ ఇన్ స్ట్రాంగ్ ఇంటరాక్షన్ ఏమో, దిస్ ఇస్ సెకండ్ వన్. నెక్స్ట్ థర్డ్ వన్ ఏంటి, వీక్ ఇంటరాక్షన్. వీక్ ఇంటరాక్షన్ లో మనకి ఏమేమి వస్తాయి, మ్యూ వస్తుంది, ఎలక్ట్రాన్ వస్తుంది, నెక్స్ట్ న్యూ వస్తుంది. ఇవన్నీ వీక్ ఇంటరాక్షన్ విత్ S is equals to 1/2. S equal to 1/2. నెక్స్ట్ ఇందులోనే ఫోర్త్ వన్ ఉంది. ఇన్ దిస్ ఓన్లీ ఫోర్త్ వన్, massless bosons. Massless massless bosons. ఈ massless bosons లో మనం ఎగ్జాంపుల్ కై తీసుకుంటాము. ఈ కై ఇట్లా వస్తుంది ఎక్స్ షేప్ లో కై. ఈ కైకి స్పిన్ S equal to 1 తీసుకుంటాము. నెక్స్ట్ సపోజ్ గ్రావిటేషనల్ ఉంది అనుకోండి మనకి. నెక్స్ట్ ఫిఫ్త్ వన్, వాట్ ఈస్ ఫిఫ్త్ వన్, గ్రావిటేషనల్ ఉందనుకో, అప్పుడు స్పిన్ ఈక్వల్ టు 1/2. సో ఈ 5 కేటగిరీస్ మొత్తం మన కన్జర్వేషన్ ఆఫ్ యాంగులర్ మొమెంటం ఉంది. కన్జర్వేషన్ ఆఫ్ యాంగులర్ మొమెంటం లో ఫస్ట్ వన్ ఏంది, స్ట్రాంగ్ ఇంటరాక్షన్ లో ఫెర్మియాన్స్ లిస్ట్ రాసాం. నెక్స్ట్ స్ట్రాంగ్ ఇంటరాక్షన్ లో బోసాన్స్ లిస్ట్ మెన్షన్ చేసాం. నెక్స్ట్ వీక్ ఇంటరాక్షన్ మెన్షన్ చేసాం. నెక్స్ట్ మాస్లెస్ బోసాన్స్ రాసాం. నెక్స్ట్ గ్రావిటేషన్. అంటే డిఫరెంట్ కేసెస్ లో వాట్ ఈస్ ఇట్ స్పిన్ ఇస్ మెన్షన్డ్. This is about conservation of angular momentum. After conservation of angular momentum, next one we have conservation of energy. And now just see the conservation of energy. Suppose I took energy check చేద్దాము. I took K, pi minus, pi plus, pi naught. Minus charge, positive charge. Just I am writing about charge. Minus charge, positive charge, 0 charge. Here 0. It is satisfied or the rest it is this is conserved. It is conserved అయింది. This is conserved because LHS side, LHS side is matching. This is conserved. And K equal to pi plus pi minus is allowed since its rest mass energy on both sides is equal. Now check this one, is it conserved or not? What is the next equation? Pi minus plus pi plus implies 2 pi naught plus n. Imagine pi minus pi plus, ఇక్కడ 0 ఉంది. Here pi naught, charges only, charges 0 అయిపోయింది. ఇక్కడ 0th charge ఉంది, ఇక్కడ nucleus ఉంది. So this one is forbidden. And what about this one? 1 minus and 1 plus. Here 0, here n is 0. This is allowed. Why this is allowed means masses of LHS side is equal to masses of RHS side. Next, charge. So charge is in terms of what we have charge, in terms of +1, -1 or 0. Just check here, plus. Its charge is 2. This side 2 plus 0 equal to 2. So this is conserved, match అయింది. ఇది చూడండి 1 plus 1, ఇది 2 అయింది. ఇక్కడ 2 minus charge plus charge. So this is also conserved. ఇప్పుడు ఇది కన్సర్వ్ అయిందా చూడండి, 1 plus 1 2 వచ్చింది ఇక్కడ. ఇక్కడ 1 plus 1 plus 2 3 వచ్చింది. 2 LHS లో ఉంది, 3 RHS లో. సో దిస్ ఈస్ నాట్ కన్సర్వ్డ్. LHS RHS చార్జెస్ ఈక్వల్ అయితే కన్సర్వ్ అయినట్టు, అయితే దిస్ ఈస్ నాట్ కన్సర్వ్డ్. నెక్స్ట్ వన్ ఇస్ lepton number. Next, what are the things? Very few minutes I will wind up. Lepton number ఏమేమి ఉంటుంది? For electron, muon, neutron కి lepton number 1 ఉంటుంది. Next, baryon numbers. నెక్స్ట్ ఐసోస్పిన్. ఐసోస్పిన్ అనుకోండి, ఇప్పుడు మనకి మ్యూ నంబర్ ఆఫ్ స్టేట్స్ ఎన్ని ఉన్నాయి? ఇప్పుడు సపోజ్ మ్యూ అనుకో, మ్యూ ప్లస్ మ్యూ మైనస్ ఉంది. అంటే ఇప్పుడు ఇక్కడ ఎన్ని ఉన్నాయి? నంబర్ ఆఫ్ స్టేట్స్ 2 స్టేట్స్ ఉన్నాయి దీనికి. ఇప్పుడు సపోజ్ నేను పయాన్ తీసుకున్నాను, పయాన్లో ఎన్ని ఉన్నాయి? పై ప్లస్ పై మైనస్ పై 0. హియర్ హౌ మెనీ స్టేట్స్? 1 2 3. హియర్ టోటల్ is 3 states. Next I am taking proton, antiproton, 2 ఉన్నాయి, 2 states. So conservation of spin, isospin means it shows number of states of the element. Number of states of the element is calculated in this. Next is last one is hypercharge. 2 is there more, hypercharge and strangeness. Hypercharge means this hypercharge is twice the average charge of the particle group. మనకి పార్టికల్ యొక్క ఛార్జ్ కి ఇది ట్వైస్ ఉంటుంది. సపోజ్ హియర్ K ప్లస్ K నాట్ తీసుకోండి. సో ఇటు ఛార్జ్ ఏమొచ్చింది? +1 ఉంది. 0 + 1 కి 1 వచ్చేసి. సపోజ్ K మైనస్ K నాట్ తీసుకున్నాను, ఇట్స్ ఛార్జ్ బికమ్స్ -1. సో ఓవరాల్ కంక్లూజన్ ఇస్ hypercharge is twice that of the particle charge. Next, the last one is strangers. Strangers is represented with S. Strangers is represented with S. For sigma plus, this stranger is for sigma plus S value equal to -1. For K plus, this stranger value S is equal to +1. For pi, this stranger is equals to 0. Here pi plus అంటే +1 +1, ఇక్కడ 2 అయింది, ఇక్కడ +1 +1 2 అయింది. Even it is forbidden, because why it is forbidden? Because K plus value is -1. In the strangeness, we have K plus value is -1. For that, it is forbidden. So this is about elementary particles, how it is conserved. Conservation of loss. Conservation of loss is completed. In this, only one topic is left in this unit. The topic is quarks. This quarks we will see in the next class.